Thermoregulation is the process of maintaining a constant body temperature. It's an example of a negative feedback loop where there's a receptor, and if there's movement away from the set point, then there's a response that occurs to bring the condition back to that set point. That's what a negative feedback loop does. And in thermoregulation, the receptor is the hypothalamus, and that's in the base of the brain. And it sets the temperature at 37 degrees. It detects the temperature of the blood. If the temperature increases above 37 degrees, certain things responses occur in the body. The first one is perspiration or sweating, and when sweat evaporates, then heat is taken away from the body. The next one is that there's the capillaries of the skin. Capillaries are the small blood vessels, and the capillaries in the skin, they actually dilate or open up, and that allows more blood to move to the skin so that heat can then radiate away from the body. Another thing that happens is that the metabolic rate is decreased. Cells burn glucose to produce energy, and a byproduct of that is heat, and that's actually what keeps warm-blooded animals warm. On a hot day, to avoid contributing to that increased temperature, the amount of glucose that's burnt actually decreases, so there's a decrease in the metabolic rate, and that's the reason why you feel less hungry on a hot day, and also the reason why you have less energy. Now, if temperature decreases below 37 degrees, well, there's a different set of responses that occur. The first one is goosebumps, and that is the hairs on the skin that stand up, and that protects the skin from wind and also traps a small thin layer of warm air around the skin. It doesn't work as well on humans as it does on other animals because we have less hair. And so, just like we saw when the temperature was warm, skin capillaries dilate. Well, this time, skin capillaries constrict. And that is that there's the capillaries actually close somewhat to reduce the amount of blood going to the skin. And that's to avoid heat being lost through radiation. And that's the reason why your skin, and particularly your lips, look blue when you're cold, and that's the reason why your fingers feel cold, and it's also the reason why people get frostbite on their fingers and their nose, the extremities, before they do on the rest of their body. So when you're hot, when somebody's hot, their skin might look red, and when they're cold, their skin looks blue. We also see shivering, which is an involuntary contraction of skeletal muscles. So the muscles of the body, they shake uncontrollably, and because that's producing work, that generates heat to keep you warm. And just like we saw a decreased metabolic rate when you're warm, well, we have an increased metabolic rate because cells are burning more glucose, producing more energy and releasing heat in the process. And so that's the reason why you feel hungry on a cold day, and I guess theoretically have more energy. So all of these processes are a negative feedback loop working to bring the temperature back to that 37 degree